Hi everyone, welcome to GTech Techno Solution Private Limited. We are going to discuss about divisibility of numbers. These are the topics that we are going to cover in this session. We'll be seeing the general rule for divisibility of numbers followed by some interesting examples. So we are going to see the rule number 1. If you say a term is divisible by, when you divide one number by another, the result is a whole number. So that is the condition which you emphasize in this phrase divisible by. That is, if you say 965 is divisible by 5, it means that if you divide 965 by 5, that gives you a whole number to be the answer. So in this case, we can say that the number is divisible by another number. If a number is divisible by another number, then it is also divisible by all the factors of the other number. That is, if 965 is divisible by 25, in that case 965 will also be divisible by 5, which is a factor of 25. Your divisibility tests let you to analyze that if one number is divisible by another without performing much calculations. So let us see how we can do the divisibility test for 2. If a number is divisible by another number, then it is divisible by all the factors of the other number, which is a general rule. So here we are going to apply this in particular for 2. So if a number is divisible by 2, if its last digit is either 0, 2, 4, 6 or 8, so we are going to guess some of the numbers, whether they are divisible by 2 or not. We have to guess whether 16 is divisible by 2 or not. Yes, it ends with 6, hence it is divisible by 2. Your answer is right. Whether 348 is divisible by 2. Yes, it is divisible by 2 as the last number ends with 8, which is a multiple of 2. 2, 4, 6 and 8 are multiples of 2. Is 105 divisible by 2? No, since the last digit, which is in units place, is 5. It is not a multiple of 2. Is 13 divisible by 2? No, since the last digit is 3, which is not divisible by 2. Hence, these are the digits which are divisible by 2. And these are not divisible by 2. So this is the divisibility rule for 2. Any number which is an even number that is ending with the multiples of 2 will be divisible by 2. Next we are going to see the divisibility rule for 3. A number is said to be divisible by 3 if the sum of the digits is also divisible by 3. If the sum of the numbers is evenly divisible by 3, then the number is divisible by 3. If you see, for 47, 4 plus 7 will give you the value to be 11, which is not perfectly divisible by 3. Whereas in case of 48, 4 plus 8 is equal to 12, which is perfectly divisible by 3 in the factor 4. That is, 4 threes will give you 12. So hence 48 is divisible by 3. Moving on, we have the next divisibility rule to test for 4. A number is said to be divisible by 4 if the number formed by the last two digits, that is, the numbers at ones and tens unit, is divisible by 4. The last two digits are evenly divisible by 4. So if you see, the last digit, that is 9, is not divisible by 4. Hence, it does not satisfy the divisibility rule for 4. Whereas 37, that is the last two digits, divided by 4. So 37 divided by 4, you get a remainder of 1. Hence, 37 is not divisible by 4. Whereas in case of 24, 24 divided by 4, you'll get the remainder as 0. So the remainder turns out to be 0 since the number is divisible by 4. So 724 is divisible by 4. So this is the divisibility rule for 4. Next we have the divisibility rule for 5. A number which is divisible by 5 will be ending in either 0 or 5. That is, any number which is ending with 0 or 5 will be divisible by 5. Since in this number we have the last digit to be 0, it will be divisible by 5. Yes, your answer is right. Here if you see, the last digit is 0. Hence this number is divisible by 5. In this number, we have the last digit as 5. Hence, the number 98,765 is divisible by 5. Next we have the divisibility rule for 6. A number is said to be divisible by 6 if the number is divisible by both 2 and 3. A number is even if it is a multiple of 2. 2, 4, 6, 8 and 0 are some of the multiples of 2. The sum of the digits is divisible by 3. Then the number will be divisible by 6. Let us take the number 23,754. So the sum of the digits will be 2 plus 3 plus 7 plus 5 plus 4. So that gives you a total of 21, which is divisible by 3. That is, sum of the digits is divisible by 3. Perfectly. Hence, and your number is an even number. Hence, it will be divisible by 2 as well. The last digit is 4. Since your number satisfies both of the condition that the number in the units place is even and the sum of the digits is divisible by 3. Hence, the number 23,754 is divisible by 6, as it satisfies both the condition that it should be divisible by 2 and 3. Next we have the divisibility rule for seben. To test whether a number is divisible by 7 or not, you have to double the last digit and subtract it from the remaining leading truncated number. If the resultant is divisible by 7, then so was the original number divisible by 7. So here we have an example where 3101 should be checked whether it is divisible by 7 or not. You have to take off the last digit and double it and subtract it from the remaining leading truncated number. On doubling 1, you get 2. And you have to subtract it from the remaining number. So 310 minus 2 will give you 308. And again you have to take off the last digit, which is 8 over here. Double it, so that gives you 16, and you have to subtract the double number from the remaining number. So 30 minus 16 will give you 14. 14 is divisible by 7. So in this case, your answer is that 3101 is divisible by 7. Next we have the divisibility rule for 8. A number is said to be divisible by 8 if the number formed by the last 3 digits, that is the ones, the tens and the hundreds, divisible by 8. The last 3 digits are all 0. Or the last 3 digits should be divisible by 8. Only in these two conditions we can say that a number is divisible by 8. If you see, we have an example over here. 7,37,648 is the number. Here, your 648, which is the last 3 digit, is divisible by 8 perfectly, which gives the remainder to be 0. Since the remainder of the last 3 digits on dividing it by 8 is 0, your number 737648 is divisible by 8 as well. So this is the divisibility rule for 8. Next we have the divisibility rule for 9. A number which is divisible by 9 will be having a sum of digits which is divisible by 9 as well. That is, the condition for a number to be divisible by 9 is that its sum of digits should be divisible by 9. Here you have 72. To check whether it is divisible by 9, we have to sum up the digits. That is 7 plus 2 gives you 9. So the remainder of 9 divided by 9 will be 0. That is, the remainder of this division will be 0 since it is perfectly divisible. So this says that the number 72 is divisible by 9. Next we have the divisibility rule for 10. A number is said to be divisible by 10 if the last digit is 0. That is, the condition for a number to be divisible by 10 is that it should end with 0. Here we have a few examples to illustrate this. We have the number 550 whose last digit is 0. Hence 550 is divisible by 10 since the last digit is 0. And similarly, over here we have 1,27,890. Since the last digit is 0, it is divisible by 10. So this is the divisibility rule for 10. Moving on, we have the divisibility rule for 11. So to find whether a number is divisible by 11 or not, you have to find the difference between the sum of the digits at the odd and the sum of the digits at the even places in a given number. And the difference should be either 0 or a multiple of 11. Then the given number will be divisible by 11. To make things clear, let us take an example. So we have a number over here as 1925, which is divisible by 11. Let us see how. You have to find the difference between the sum of the digits at the odd places and sum of the digits at even places. So at odd places we have the digits 1 and 2. So their sum is equal to 1 plus 2, which is equal to 3. And the digits at even places is 9 and 5. So sum of their digits is 9 plus 5, which is equal to 14. So next we have to find the difference between the sum of the digits. So the difference between the sum of the alternative digits is 14 minus 3, which is equal to 11. It is a multiple of 11. Hence, the number 1925 is divisible by 11. Moving on, we have the divisibility rule for 13. To check whether a number is divisible by 13, you have to add 4 times the last digit to the remaining leading truncated number. If the result is divisible by 13, then so was the first number. So how to do this? Let us take an example to make things clear. We have the number 559. We have to check whether this number is divisible by 13 or not. So then you have to add 4 times the last digit to the leading truncated number. So the last digit is 9. 4 times 9 is nothing but 9 into 4, which gives you 36. you have to add 36 to the remaining truncated number, that is 55 plus 36 will give you 91. 91 is divisible by 13. Hence, your number 559 is also divisible by 13. So this is how the divisibility rule for 13 works out. Next we have the divisibility rule for 17. So to check whether a number is divisible by 17 or not, you have to subtract 5 times the last digit from the remaining leading truncated number, and the result which you get, if the result is divisible by 17, then the number will also be divisible by 17. You have 3978 as the number, and you have to check whether it is divisible by 17 or not. Your last number is 8. So 8 has to be multiplied with 5. That is 8 times 5 is equal to 40. Subtracting 40 from the remaining truncated value, that is 397, you get the value as 357. So now you have to find whether 357 is a multiple of 17 or not. So we are taking the last digit, multiplying it by 5, you get 5 times 7 is 35, and we have the leading truncated value to be 35 as well. So 35 minus 35 will give you 0. Hence, the number is divisible by 17, since you got your result to be 0, which says the number is a multiple of 17. Moving on, next we have the divisibility rule for 19. You have to add 2 times the last digit to the remaining leading truncated number. So 2 times of the last digit. We have an example over here, 1,01,156. So to check whether this number is divisible by 19 or not, we have to multiply the last digit with 2. So 6 multiplied by 2, you get 12. Substitute over here, and you have to add this number to the remaining leading truncated number. So your leading truncated number is 10115. Adding this number to this, you get 10127, that is 10,127. Again you have to take your last digit, multiply it by 2. So that gives you 14. Add it to the remaining leading truncated number. That gives you 1026. Repeat the same process. You have to take the last digit, multiply it by 2, add it to the remaining truncated number. That gives you 114. We know that 114 is a multiple of 19 with the factor 6. So since our final number over here is divisible by 19, it implies that this number 101156 is divisible by 19 as well. So this is how you have to check whether a number is divisible by 19. Thank you so much for joining GTech. You would have got a very good idea about the divisibility of numbers and how you can check whether a number is divisible with the numbers or not. Thank you.